Hello everybody, and welcome back to another Algebra 2 Big Ideas lesson. Today we're talking about section 3.4, using the quadratic formula. The quadratic formula is a formula that we can use to solve any quadratic. Anything that looks like ax squared plus bx plus c equals 0. Now, just because you can use it in every situation doesn't mean it's the best to use in every situation. The form of your answer might look a little bit strange, but regardless, it will be the correct answer. We're going to talk about how to derive the quadratic formula, meaning how do we get there. But first, I think it's nice to preview what this quadratic formula looks like. So let's flip the page to page 14, and let's take a look. The quadratic formula looks like this. Let's say that a, b, and c are real numbers such that a is not 0. Then ax squared plus bx plus c equals 0 is our equation. That's our quadratic equation. And the solution is, oh geez, this is a mess, isn't it? X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. How on earth would we even use such a big equation? Well, believe it or not, this equation, the more we practice it, will become easier and easier to use. Because really, all you need to know how to do is how to multiply, how to subtract or add, and how to square root, and you'll get your answers. The key is, in order to make this work, your quadratic must be of the form ax squared plus bx plus c equals 0. It has to look something like this. We're going to do an example. Afterwards, we're going to talk about how we get this formula. And then we're going to see some other applications of it. So let's try solving an equation with two real solutions. It says to solve x squared plus 3x equals 5 using the quadratic formula. Again, to do anything with the quadratic formula, the first thing we have to realize is one of the sides has to equal 0. And we don't have that here. We have it equaling 5. So what can I do to make this equal 0? Well, of course, we're allowed to subtract 5 from both sides. We end up with x squared plus 3x minus 5 equals 0. Now, this is in the perfect form to use the quadratic formula. To use the quadratic formula, we need to identify our a, b, and c values, then just plug them into this equation, and we're basically done. We just need to simplify. It's relatively easy to see what our b value is. The b value is always the one that's in the middle. It's relatively easy to even see our c value. Our c value here is negative 5. But what's our a value? Well, you may recall from Unit 2 that anytime we don't see a number in front of x squared, we imagine it as 1. So our a value is just 1. A equals 1. So now we just plug into this formula. The formula goes x is equal to negative b. So instead of negative b, I'm going to write negative 3, since b is 3. Plus or minus the square root of b squared, which is going to be 3 squared, minus 4 times a, our a is just 1, times c, our c is negative 5, all divided by 2a. And it's the entire thing that gets divided by 2 times a. So all we need to do now to solve it is simplify. Well, we know, for instance, that, let me write this down, we're going to have negative 3 plus or minus the square root of, what's 3 squared? Well, that's just 9. And what's 4 times 1 times negative 5? Well, it's just negative 20. So it's 9 minus negative 20, which we can rewrite as 9 plus 20, because it's minus a negative. And 2 times 1 is 2. So our final answer here, our final two answers for x are, believe it or not, x equals negative 3 plus the square root of 29 over 2, and x equals negative 3 minus the square root of 29 over 2. Done. These are our two answers. Like I mentioned, weird looking answers, but these are correct. In fact, I want to quickly calculate out what these two numbers will be. So to plug this in, let's take a look. In our calculator, we're going to do negative 3 plus the square root of 29. See what that is. And then make sure to divide it by 2, because it's over 2. It looks like this answer is around, so x is around 1.19. As for the other one, negative 3 minus the square root of 29 is this, which we divide by 2, and get negative 4.19. There we go. So these are two x-intercepts. In fact, if we wanted to sketch the graph, we've actually got quite a bit we can do here. Like, for instance, we now know some of the hardest things to find in standard form, because this is the standard form of a quadratic, right? We now know where our two intercepts are. So if this is negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5, and I'll count up on the y's as well. What do we know about this now? We know a great deal, actually. We know, for instance, that we have an x-intercept at 1.19, so it's like just above 1, maybe right there. We have another x-intercept at negative 4.19, it's just below negative 4, right there. What else do we know if we're given standard form? What's the easiest thing to find in standard form? Well, recall that the c value is your y-intercept. So we also have a y-intercept down here at negative 5. And what way should our graph face? Should it be up like a cup or down like a frown? If you said up like a cup, you're correct, because our a value is positive. We don't have to flip it. So already, just from this, we know that our parabola is going to look something like this. There we go. That's our parabola. That's a sketch of our parabola. And we're done. Pretty nice, right? Now, before we move on to other problem types, I want to show you how we get such a strange equation. Remember, our end goal is to end up with x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is something that I do expect us to remember by the time we take the test, and to help us remember it, there's a certain song we're able to listen to. I've posted this in the description of the video. This is a song that has helped even me remember the quadratic formula. It's really catchy, and I really think it'll help with memorizing this formula. Just give it 1 or 2 listens, and I'm sure it'll be stuck in your head. We are going to now derive this quadratic formula. Derive is another word for like create from something else. We want to create this weird formula from using a quadratic equation in standard form. So a quadratic equation in standard form is ax squared plus bx plus c equals 0. And our goal is to eventually end up with something like this. Let's take a look and see how we can do it. Notice that in our equation up here, we have an x by itself. So one thing we're going to need to do is find a way to get x equals something. The best way that I can remember to do this is actually by completing the square, like from our last notes. You see how like in our last notes we would end up with x equals something that looks suspiciously like this? Well, let's try using completing the square to get there. So we start with ax squared plus bx plus c equals 0. And we're going to complete the square even without any numbers. Let's see how it's done. We know that to complete the square, the first thing we should do is get rid of our c value and move it to the other side. This will give us some space to put in our own perfect c value. This will be negative c plus some blank. But we also have an a value, right? We have our ax squared. Anytime we have an a value in front of our completing the square problem, we have to divide everything by that a value. We could have done it at the very start, but I'm choosing to do it here. You would get the same answer either way. I'm going to divide everything by a. Well, ax squared divided by a is just x squared. That's the easy part. But bx divided by a, we're going to get this weird fraction, bx over a, plus something. Negative c divided by a is just negative c over a. This is again plus some blank. And we really want to figure out a way to fill in this blank with something that'll make a perfect trinomial. How do we do it? How do we get there? There's a rule we learned that helps us with this. Our rule is our c value is just going to be our b value cut in half, then squared. So we really need to do b divided by a cut in half, and then squared. Well, b divided by a cut in half is the same as b over 2a. And of course, we want to have it squared, right? And whatever we do to one side, we want to do to the other. So what we really want to do is we really want to have this be b over 2a squared. Okay, it looks really messy, but we knew we were getting into a messy situation here. Let's keep going. First things first, I want to keep this left side just as is for now. We'll see why in a second. But I want to keep this just as is for this step so we don't have to confuse anything. X squared plus bx over a plus b over 2a squared equals. Now our negative c over a is fine as is, but b over 2a squared, well, that's the same as if we just took the square and put it on the b, and took the square and put it on 2a. So we would end up with plus b squared divided by 2a times 2a is 4a squared. Now, wouldn't it be nice if we could somehow simplify this right side a little bit, right? It'd be kind of nice. The problem is, in order to combine fractions, you have to have the same denominator. So I'm going to put another box on the side here, just so we can do this math over here. The question is, what can we do to negative c over a to make it have the same denominator here? Well, we can multiply the top and the bottom by 4a. Remember, we want to get the denominators by themselves, or to be the same. 4a times a is 4a squared. That'll make it so it's the same. But to give an equivalent fraction, we have to do the same thing to the top. So we would get negative 4ac over 4a squared. We can rewrite this then as, again, our left side will stay the same because I don't want to mess with that just yet. That's a whole different thing that we're going to worry about. Instead of negative c over a, we could write this as negative 4ac over 4a squared plus b squared over 4a squared, which we know can combine. We get, on the right side again, all we're worrying about is the right side for right now. We get b squared minus 4ac over 4a squared. You could write it the other way around, but it's nicer to see it where it's b squared minus this instead of negative this plus b squared. So we get b squared minus 4ac all over 4a squared. And this part looks a lot like the quadratic formula, right? There's our b squared minus 4ac. It's a very important thing, as we'll learn, with the quadratic formula. Next up, we want to take care of this left side and make it a little more simple for ourselves. How do we do it? Well, do recall that anytime we're completing the square, anytime we're completing the square, we really want to factor this left side as a plus b squared. It's just the square root of your first term plus the square root of your second term squared. So we're allowed to rewrite this side as x, because that's the square root of x squared, plus the square root of b over 2a squared is just b over 2a. And we squared the whole thing. So this equals b squared minus 4ac all over 4a squared. And now we can finally start to get x by itself. Because what step can we start to do to unravel this left side? To get rid of a square, we can square root both sides. Okay, the square root of x plus 2 over b, b over 2a squared is just whatever's inside of the parentheses. So it's just going to be x plus b over 2a equals the square root of b squared minus 4ac cannot be simplified. So we're going to keep that as the square root of b squared minus 4ac. But the square root of 4a squared can be. I mean, think about it. To get to 4a squared, we squared 2a. So this step just lets us undo it. The square root of 4 is 2. The square root of a squared is just a. So it's all over 2a. Ooh, we're getting close now. And don't forget, anytime you take the square root, you must get a positive and a negative answer. So it's positive and negative, our answer. Well, what's the last step we need to do? To get x by itself, we subtract b over 2a from both sides. And once again, we have a situation where the denominators are the same. It's negative b over 2a plus or minus this over 2a. So we can rewrite this as x equals, instead of writing it as negative b over 2a and then this over 2a, we can just put it all over 2a because they have the same denominator. So it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there we go. That's the quadratic formula. We have figured out how to get the quadratic formula by completing the square. All the quadratic formula is a way to complete the square with any combination of a, b, and c. Let's flip. Well, actually, before we flip, let's talk about one more problem. Let's talk about letter b here, because there's something that confuses quite a few people with this. Remember, the only way we can use the quadratic formula, it's a nice cheat code we have, but the only way we're allowed to use it is if it looks like ax squared plus bx plus c equals 0. So anytime you're trying to get your equations in order, we know we want to get 0 on this side, so we'll add 7x. It has to go in order. It has to go with your ax squared, so 2x squared, plus bx has to come next. Even though we added it on, we can't write 2x squared plus 4 plus 7x. It has to be in the right order in order to solve. I actually want you to pause the video and try to see if you can solve this one. Pause the video here and try using the quadratic formula to see if you can solve letter B. How do we do? Did we get negative 7 plus or minus the square root of 17 over 4? I've showed one of the intermediate steps here, just so you can check your work to make sure you plugged in everything in the right spots. But I don't like to show every single step with these because a lot of it is just multiplication, addition, subtraction, and then square rooting if possible. So I usually will just write down the form and then just skip to the answer. If you want to try out A and C, I recommend it. For A, here's going to be your answer so you can check your work. This can simplify when you simplify the square root to this, and since 6 and 2 can both be divided by 2, it simplifies down to this very nice looking answer. And C will get you a wild looking answer, but this will be the correct one. Let's flip the page and let's talk a little bit more about some other results with the quadratic formula. So, example number 3 has us solving an equation that has one real solution. Well, what does that mean? I'm telling you that this parabola will only ever touch the x-intercept, or the x-axis, I should say, once. It'll have one x-intercept. So let's start off by getting everything on the same side. I'm going to choose to minus 12x and add 4 to both sides, giving us the following equation. We get 25x squared. Negative 8x minus 12x is negative 20x. Then we have a plus 4 equals 0. And of course, we can plug in to use the quadratic formula. X is equal to negative negative 20. What's negative negative 20? It's just 20. Plus or minus the square root of, what is negative 20 squared? Well, negative 20 squared is positive 400. That's our b squared. Minus 4 times 25 times 4 all over 2 times 25, which we know is 50. And wait a second. What is 4 times 25 times 4? This will give us 20 plus or minus the square root of 400 minus 4 times 25 is 100 times 4 is 400. We're going to get something weird here. Over 50. Well, this is just going to be 20 plus or minus the square root of 0. 400 minus 400 is 0. And the square root of 0 is just 0. So what's our answer? Our two answers are 20 plus 0 over 50. That's 20 over 50. And the other answer is 20 minus 0 over 50. That's just 20 over 50 again, which we know can be simplified to 2/5. Everybody, we only get one answer here, and it's weird. It's 2/5. No, sorry. Yes, I did this right. We end up getting just 2/5. When we sketch this graph then, there's only going to be one place where it crosses the x-axis, at 2 over 5. So I'm going to make this a very stretched out graph. 1, 2, and we have my y's here. Our only x-intercept is right here, 2/5 of the way to 1. And of course, our graph is going to be up like a cup because our a is positive, And because our a is such a huge number, our graph is going to be like almost perfectly vertical. It's going to be like super, super stretched out by a factor of 25. So what do we know? If you only have one x-intercept for a parabola, that's your vertex. Our vertex is at 2/5, 0. Kind of interesting, right? There's one more answer type we might get, which is imaginary solutions. So I actually want you to try this one out on your own. Try the full process and check back here after pausing the video. How do we do? If we take a look here, we see that our square root becomes negative. But we know how to deal with that. We take an I out and then take the square root of the positive version. This is just 6i. One thing to note is, if both things are divisible by the denominator, you want to simplify it. Negative 4 divided by negative 2 is positive 2. But 6i divided by negative 2 should be negative 3i. But again, since we have plus or minus, the sign on the 3i doesn't really matter. You could write it as negative 3i, or you could write this 3i. Either way, your answer will be both of them. It'll be 2 plus 3i and 2 minus 3i. So what's the deal here? If we do not have a real solution here, something interesting happens. First off, what's our y-intercept? Our y-intercept will be all the way down at negative 13. So this is like negative 13. What way is our graph facing? Well, it's going to be down like a frown since we have a negative a value. But where are x-intercepts? As of this point, we don't know. They're not on the x-axis, though, otherwise there'd be real answers. We learned that anytime you have imaginary roots float off the graph. Floats off of the x-axis, I should say. So our graph is going to look something like this. In the next couple of units, we are going to be learning how to actually graph imaginary numbers, but not quite yet. All right, we've got one last concept to talk about, and then we'll be basically good to go for these notes. Well, two more, really. We've got this idea called the discriminant. The discriminant is whatever goes under the square root sign. And depending on what goes under the square root sign, we can get a different number of answers. For instance, what happens when b squared minus 4ac is positive? We can take a look at our first examples for this. How many answers did we get when we had, for instance, the square root of 29? We got two roots, two real roots. So when your discriminant is positive, when your discriminant is bigger than 0, we say that we get two real solutions. I want to abbreviate it as sols. Two real solutions. And our graph, of course, is going to have two roots. I'll just put an example here, and then just make our graph. Bam. Cool. But what happens when our solution is 0? What happens when it's exactly 0? Do you remember the example we did at the top of this page? We only got one root at 2/5. So we can say we get one real solution. One real solution. And when we have one real solution, our graph just sort of touches the x-axis. Maybe I'll make mine touch right here, and it'll go like this. It just touches the x-axis once. Doesn't really go through it twice. And what happens when we had a negative number? What happens when our discriminant was negative? When our discriminant was negative, like negative 36, we got imaginary solutions. So for imaginary solutions, we get two imaginary sols. And our graph is going to be floating off of the x-axis somehow. Maybe it's above, maybe it's below. I'm just going to write it above since I made all these other ones facing up. So maybe our graph looks like this. Sure. And our intercepts aren't really intercepts. They're just floating off. They're imaginary roots. All right. You might be asked to find the discriminant. And when you find the discriminant, you actually immediately know how many solutions there are and what type of solutions there are. You know that if your discriminant's positive, you're going to get 2 real solutions. If it's 0, you're only going to get 1 solution. And if it's negative, you're going to get imaginary solutions. So take a minute and calculate these discriminants. Remember, the discriminant is just the b squared minus 4ac part. You don't need to square root it. Try these 3 out, pause the video, and come back after you have some answers. How do we do with calculating these? Hopefully we saw that this one will equal 0. So whenever it equals 0, we have 1 real solution. It's going to be our vertex. When it's positive, like 3, we're going to have 2 real solutions. And when it's negative, like negative 194, that was a tough one, we get 2 imaginary solutions. Beautiful. On the next page, there is some additional practice with writing equations. I'm going to leave these as challenge problems for you. Can you write a pair of numbers a and c so that our equation has 1 real solution? Can you find a pair of integer values for a and c so that there's 2 real solutions? These are thinking problems, but remember, you have 1 real solution if b squared minus 4ac equals 0. And we know our b. So can you find an a and c that'll make it happen? Either way, I'll leave these to you as challenge problems. Let's flip the page. Right up here, we have a couple of methods for solving quadratic equations. All the ones we've learned in this unit, in fact. There were 5 in total, and it tells you here when to use these. Graphing is best when approximate solutions are okay. Using square roots is when you just have something that can be written as u squared equals d, where u is an algebraic expression. So basically when you have a perfect square, you can square root. Factoring is nice when you can look at a quadratic equation and go, that can be factored easily. Completing the square can be used for any quadratic equation, but it's a lot easier when you won't get a fraction for your c, so when b is an even number. And the quadratic formula can be used for really any quadratic equation. This is the preferred method of most mathematicians. But these other ones have their merits. The last thing I want to talk about is a little bit of a physics problem here. Those of you who've taken physics this year, which I know is not many of you, may know this stuff already. For those who don't have physics, anytime you throw or drop something, the arc that it follows is a parabola. It can be modeled by a quadratic equation. So like if I was to throw a ball from the origin 0, 0 over to my friend at maybe x equals 10, when I throw the ball, it'll go up a little bit, and then it'll go down a little bit, following that quadratic arc. There's 2 functions that we can use to help us out with this. 2 of them. Anytime an object is dropped, we can use this formula here to model it. H equals negative 16t squared plus h0. Now, let's talk about what each piece is. H is the height in feet of an object. T is the time in seconds. highlight that one in orange. h0, or h0, is the initial height in feet. Most of the time you see a 0 in the denominator there. Well, not really in the denominator there, but in the subscript, it usually means that it's a initial amount. The last thing is that sometimes the object is not necessarily dropped. If it's dropped, we can use this equation and just use these three ideas. H is your feet, t is your time, h0 is the amount of feet that you started at. But anytime you throw an object, something else factors in. The speed of what you throw. v0 is the object's initial vertical velocity. So if you're throwing an object straight up, the initial vertical velocity is probably going to be pretty big because it's just going straight up. If you're throwing the object wide, like this, its initial vertical velocity might not be that much, but its horizontal velocity will be huge. Anytime an object is thrown, we want to use this equation. H equals negative 16t squared plus v0t plus h0. So as you can see, the value of this velocity could be positive. If the vertical velocity is positive, it means we're throwing an object up somewhere. If it's negative, if our initial vertical velocity is negative, it means we're like throwing an object down. Or it could be 0. Maybe you're talking about like a pitching machine, where we'll pitch a baseball at you. That'll pitch it straight forward. So the initial vertical velocity will be 0 because it's not really going up or down, it's going straight to the side. If we flip the page, we can see how we can use some of these. So, a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. And the juggler catches the ball when it throws back to a height of 3 feet. The question is, how long is the ball in the air? So we've got this situation. We've got our juggler here. He's just chilling. And he throws a ball into the air. It goes dot, 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 dot. And then it goes down, 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 down. And it ends off a little bit lower than where it started. This actually will still be a parabolic arc. So we need to figure out an equation to represent this. Which equation represents throwing something? That's going to be our h equals negative 16t squared plus the initial vertical velocity times t plus our starting height. Well, let's start figuring out what to plug in here. The good news is, we know what we're trying to solve for is how long the ball was in the air for. And which variable are we looking to solve for then? T. We're looking to solve for time. Do we know an initial height? Do we know what height we're starting at with this throw? Well, yeah. It leaves the juggler's hand 4 feet above the ground. That's our h0. So this will be our h0. It has an initial vertical velocity of 30 feet per second. That one's easy to identify. That's our v0, right? That one there is going to be our v0. And the juggler catches the ball when it falls back to a height of 3 feet. That's the final height. h is our final height. H is the height for where it ends up. So it's just h. So now we have everything that we're able to plug in. We know that instead of h, we have 3. We know that instead of t squared, well actually, we're trying to solve for t, so let's leave that as t squared, right? T's are unknown, so we want to keep that by itself. Plus, our initial velocity is 30 feet per second, so we can plug in 30 times t. And our height, h0, should just be the height that we started at, 4 feet. So this is what we're trying to solve. I want you to solve this quadratic equation by using the quadratic formula. Pause the video here, and we'll check our answers and see what happens. How'd we do? We should have gotten something like this. Negative 30 plus or minus the square root of 964 divided by negative 32. It's a little bit weird. It's a little bit of a big one, but we can actually simplify this as well. Because if somebody asks you, hey, how long was it in the air for, and you give them this, they're going to look at you like you're crazy. So let's actually figure out what the two answers are here. One of the answers is gotten when it's negative 30 plus the square root of 964. One is when it's minus. So negative 30 plus the square root of 964 is this. Divided by negative 32, we get negative 0.0327. I'm just going to write this as negative 0.033. And for the other one, we'll do negative 30 minus the square root of 964 divided by 2. Whoops. Sorry, give me just one moment here. Sorry about that, I accidentally divided by 2. So it's negative 30 minus the square root of 964 divided by negative 32 is 1.908. If we're talking about time, which technically I shouldn't have had the x's here, I should have put them as t's because we're talking time now. Good catch if you caught that, because I certainly didn't until just now. If we're talking time here, what value of time makes sense to us? Negative 0.033 seconds or 1.908 seconds? Well, since time can't be negative, time is not negative, we can say that therefore, this symbol means therefore, t equals 1.9, or is approximately 1.9. There we go. It was in the air for 1.9 seconds. Perfect. With that, everybody, that is the end of our notes for today. Thank you so much for listening, and if you have any questions, feel free. Have a fantastic rest of your day.